Today we're going to be looking at an enhanced unit circle that includes angles that are multiples of 15 degrees and 75 degrees, or pi over 12 and 5 pi over 12. Now we've already looked at the double and half angle formulas, and we figured out how to figure out trig functions at these angles, 15 and 75, using half angles. So I'm not going to show you every single trig function at these angles because you need to practice it yourself, but we have looked at a few. You're going to use the same formulas to solve those. What I am going to show you is what happens when you put all that together on the unit circle. Okay, so here we have sine of 15, cosine of 15, and tangent of 15. Question is, how does this apply to the unit circle? Well, we figured out sine of 15 using the half angle formula. Like I said, you use the same application with the cosine half angle formula to figure out cosine. We also figured out tangent of 75 using the half angle formula. So you can fill the rest of these in using the half angle formulas. I'm going to review those quickly, and then we'll talk about how it relates to the unit circle. So just remember that the sine and cosine half angles are very, very similar, except for cosine of theta over 2 has a plus in the radical, the sine has a minus. So it makes sense that when you figure out cosine of 15, the only difference is the sign here. Sine of 15 is square root of 6 minus square root of 2 over 4. Cosine of 15 is square root of 6 plus square root of 2 over 4. Okay, we also used the half angle to figure out tangent of 75 using this formula. Okay, you will also notice that tangent of 15 is almost the same as tangent of 75, except it's 2 minus radical 3. And again, you're going to use the exact same formulas you used when you used half angle formulas to figure out various trig functions. For example, we did sine of 15. If you haven't watched that video yet, watch it on trig ratios at half angles. So, these are the 6 functions we're focusing on. Now, how does it relate to the unit circle? Well, let's go ahead and put some dots here. Notice that 15 and 75 can both be translated onto the unit circle. Okay, here we have 30, we have 45, and we have 60. Those are all on the normal unit circle. We can easily put 15 and 75 degrees on there. So what ends up happening is, we're first of all just going to write the trig functions at these two angles. Okay, so we know sine of 15 is square root of 6 minus square root of 2 over 4. Now how that relates to the unit circle is we can simply figure out the y value on the unit circle using this sine value. Why? Because sine is equal to y. We learned that with our set of identities, our coordinate identities. We can also say that the x value here at 15 degrees on the unit circle must be equal to square root of 6 plus square root of 2 over 4. Because cosine is equal to x, and that is the coordinate identity we learned for cosine. Now we know that tangent is x over y, right? So we can put tangent of 15 right here and know that our x over y is equal to 2 minus square root of 3. Now, we never really have to figure out x over y per se. Y over x, I should say. I'm sorry, I misspoke. Tangent is y over x. We might not ever have to figure out y over x per se, but we do know that tangent is positive in the first quadrant, negative in the second, positive again in the third, and negative in the fourth. We can use that information to translate our trig values across different quadrants. For example, if we know tangent of 15, we can easily figure out this angle over here, which is going to be 180 minus 15, so it would be 165. In fact, all we'd have to do is take this tangent value at 15 degrees and make it negative. So the tangent at 165 would be square root of 3 minus 2. You would basically, in effect, flip this, right? Because you're multiplying it by -1. So anyway, that's the whole gist of this lesson. So how can we take these 6 values and fill in the entire unit circle for any multiple of 15? Well, that's what we're going to do. So, for example, let's say we wanted to figure out the x value at 105 degrees on the unit circle. And don't forget, too, that the unit circle is in terms of radians. So at any point in time, I can put that r there next to my values to indicate that's how many radians we've gone for this arc length. Okay, and sometimes that's easy to forget, and it's also very hard to wrap your mind around that, which is why I spent so much time explaining radians. Okay, but how do we get this x value at 105? Well, if you notice, At 75, we know that cosine is square root of 6 minus square root of 2 over 4. So all we really have to do is take that x value and flip it. Okay, there is some symmetry right here, which I will draw with light blue here, and show you that basically these two points have the same x value, except this one is the negative of that because they're symmetrical around the y-axis. So we're just going to take this right here and make it negative and put it over here, which basically means the top is just going to flip to become square root of 6 minus, square root of 2 minus square root of 6 over 4. Okay, but for now, you can just put a negative in front of it because you can go ahead and simplify it later. So the point is, if you take this and make it negative, it will become that point over there, which is what we want, right? We want to know every point on the unit circle. Now, this would be 15 degrees past 90, so we're talking at 105 right here, right? And that's the concept. So, in the same way, let's say we want to figure out the y value there. Well, if you go back and look here, what's the y value at 75? According to the sign coordinate identity, it's square root of 6 plus square root of 2 over 4. So it would be exactly the same y value over here because we haven't hopped down over the x-axis. So it's also going to be square root of 6 plus square root of 2 over 4. And we can go in and we can fill in the entire unit circle based on x and y values and tangent values like I just talked about. So all the y values at the top are going to be the same. So I'll simply just take these sign values and just translate them over. And then on this side, so to the right of the y-axis, all the x values are going to be the same because cosine is x in the first and fourth quadrants. So it's the same thing you've done before. You're just applying the half angles and putting them on top of the unit circle. Now again, for tangent values, they're going to change. It's going to be positive here, going to become negative there, positive here, negative once more in the fourth quadrant. We can do the same thing for tangent of 15. So all of that being said, we're going to go ahead, well, let's do a tangent before I do that. So let's just say, for example, you wanted to figure out tangent of at 300, and what's 15 degrees less from 60? It'd be 345, right? Okay. Well, I know that my tangent value is going to look the same when it's close to the x-axis, right? It won't be the same, but it'll look the same. Just like, for example, square root of 3 over 3, that's what it is in the first quadrant. In the fourth quadrant at tangent of 330, it's a negative square root of 3 over 3. So I'm just going to take this tangent value of 15 and multiply it by negative 1 to get the tangent value of 345. So if I flip this value right here, or actually if I make it negative, it's negative 2 parentheses, negative parentheses 2 minus square root of 3, which becomes negative 2 plus square root of 3. And if you flip that, it becomes square root of 3 plus 2. And that would be my tangent value at 345. Okay, and the point is I can do that in all of these quadrants. So I would encourage you to do that activity where you fill in the unit circle yourself. However, we're not going to spend a whole lot of time on all that because it's basically just multiplying by negative 1 to figure out all the multiples of 15 on the unit circle. So that being said, when we put it all together, we get this massiveness right here. And what I like to do is list all of my x and y values out first at each point. So at 15, we have the square root of 6 plus square root of 2 over 4 for my x value, which was cosine, and then square root of 6 minus square root of 2 over 4 for sine. And again, notice how similar these are. It's very easy to remember one if you know the other, because it's just the opposite sign in the middle, at least for the first quadrant. And then tangent is 2 minus square root of 3, so that means y over x is 2 minus square root of 3. And then up here we have y over x is 2 plus square root of 3. So you can use basically just simple coordinate geometry to know that what's positive in each quadrant, what's negative, and then just take all these points and just translate them over. I remember when I first showed this to my students, they freaked out, but in all honesty, there's really nothing complicated about this. So for example, let's just pick some random point. Let's pick this point down here. Where did we get that? Okay, so for example, if you take this x value right here and multiply it by negative 1, now notice where this x value is. It's right here, right? So if you wanted to figure out this x value down here, you would multiply this x value by negative 1 and basically the square root of 2 would become positive and the square root of 6 would become negative. Okay. Also, let's say you wanted to figure out this y value right here. Well, all you'd have to do is look at the y value here that's closest to this axis, and the y value is square root of 6 plus square root of 2 over 4. But since it's down here, it's going to be flipped and become negative. So that new y value is negative square root of 6 plus square root of 2 over 4. You can do that for any point on the unit circle when you're adding these multiples of 15 degrees. So let's just actually say what these all are. 15, 75, 105, 165, 195, 255, 285, and 345. Now obviously in between these 15 degrees you have multiples of 30, so we've already got that. But for example, let's say we wanted to figure out what the tangent is at 165. Well, again, notice that at 15 it's 2 minus radical 3, and I know that tangent is negative in the second quadrant. So you literally just multiply this by negative 1. The 2 becomes negative, the square root of 3 becomes positive, and you flip it, it becomes square root of 3 minus 2. I'll do one more just so you really can get your head wrapped around this. Up here you have tangent is equal to 2 plus radical 3, right? At 75 degrees. Now let's say you wanted to figure out tangent of 285. Well, that's just, again, you're just taking that and flipping it, making it negative. So make all of this negative, and you can see you just put a negative in front of parentheses. It's negative parentheses 2 plus radical 3. You can see that at 75 and at 255, they're exactly the same. Now again, the rule is both these angles are closest to the y-axis, so they basically mirror each other, and tangent is positive in the first and third. So they're going to be exactly the same value at 75 and 255. So that's it for my explanation of the enhanced unit circle. Of course, we don't have all the angles, the original angles on here, just the additives of the 15 multiples of 15. If you have any other questions about this video, let me know.